years ago. That was for conference purposes. I think it would be wise to show you that because a lot of the information in that video is still relevant today, and in all honesty, it will do a lot better job of explaining what I'm talking about in a succinct time frame than I could do right here. So, this is actually available on YouTube, but I do, whoops, might have to escape that. Sorry. I do have it available today.
The following video is to assist in describing what threat is, how it was designed, and how it works with several walkthrough video examples. So first of all, what is meant by the term threat? If you look at the word threat in any common dictionary, you will typically get up to 3 different definitions, depending on context. The definition used to describe threat in this research is most related to the second typical definition, described here as an indication of impending danger or harm. In this context, threat can be related to anything in our world that puts us in a state that is disadvantageous when attempting to achieve our goals and objectives. An example of this in the real world that many people perform every day is driving. Driving has some risks and relationships between things like your mass, your velocity, your inertia, and your reaction time that, should something appear in front of you, could end up in your demise. Ideally, you would make an assessment of a potential threatening situation and do something about it, such as hitting the brakes or not driving as fast. Assessing the factors which contribute to a potentially threatening situation is something we do well, and also something that we can do while playing video games. Our innate understanding of danger in the real world transfers over to the virtual quite easily, especially when things are trying to kill us. In the FPS genre of games, personal factors contributing towards your own threat assessment can include things like your hit points, your armor, your weapon, remaining ammunition, and your current velocity. Other external factors may be those of your enemy, their hit points and armor, their velocity, how many of them there are, your proximity to them, your altitude over them, and whether or not they are looking at you. Some of these variables can have interesting relationships that, while naturally understood by players, can be somewhat ignored in the design of AI agents. In competitive arena shooters, where the enemy AI, or bots, are designed to emulate human performance, the factors contributing to threat and their inherent relationships should be considered with a high level of importance. So how does this affect what I am doing? Well, included in a past study, 32 participants were put through various theoretical threatening situations related to the game Quake 3 Arena. Participants rated threat very similarly across the board, but were found to have vastly different in-game threat-based behaviours. In short, it was discovered that high levels of individual player skill and experience contributed towards more conservative, survival-based behaviour. Besides just being able to move and shoot better and seeming somewhat unpredictable, more skilled and experienced players were observed to flee more frequently, play safer, pursue less aggressively, prioritise items more, and as a result, die less frequently. Conversely, less skilled or experienced players seem to die much more frequently, often for predictably illogical reasons. Two things were interpreted from this data. Firstly, that skill and experience can be tied directly to frequency of acknowledging threatening conditions. Secondly, as skill and experience increase, so do behaviour tendencies related to self-preservation. This means that as a more skilled player is more likely to accurately assess the threat of a situation and choose survivalistic behaviours, so should a bot of equivalent skill. The behaviours of engaging, fleeing, pursuing and roaming were some of the highest rated behaviours for identifying between player types, either bots or humans, in said previous study. As such, they made the primary states for the default threatbot AI to be based upon. From this, it is possible to develop a system where states can logically overlap, having a fuzzy zone where randomness can occur, and where behaviour changes can be determined by the level of threat being experienced. As the difficulty of a bot increases, these overlapping states should adjust, increasing the likelihood of preferring more conservative behaviours and decreasing the likelihood of illogical aggression. As higher levels of unpredictability was observed in more skillful players, it makes sense that the fuzzy zone would increase in size, as well as increase in the frequency at which threat-based assessments are made. Basically, a highly skilled bot should be more concerned with survival, make threat assessments more frequently, and be less predictable. While modelling the frequency and likely choice of behaviour is useful, calculating an appropriate threat value to make decisions on is not so straightforward. Variables such as health, armour, and pickup buffs can apply a somewhat linear level of threat increase if it is on the enemy, and decrease if it is on the player. However, a more linked relationship was observed when dealing with weapons and the proximity the opponents are from each other. The utility of the weapon, or in the case of the player, its desirability of use, is tied strongly to the range at which they are using the weapon. A shotgun, for example, is an absolutely terrible long-range weapon, especially to be using against an opponent at long range. On the flip side, should an opponent be using a shotgun against you at long range, the amount of threat you would probably be experiencing should be minimal. However, if they were at point blank, then you should experience a significantly higher amount of threat. This relationship of weapon desirability of use and the threat of facing against at particular ranges was observed to be a major component governing skilled players' threat-based decision-making. And so, a best-fit formulaic solution was adapted for each weapon in the ThreatBot prototype to model this observed relationship. Assuming a constant target velocity, each weapon has an exponent-mapped formula detailing its desirability of use and threat to be facing against at increasing range. This is based on similarly observed weapon usage by participants in Quake 3 Arena. The weapons modelled include the following: machine gun, shotgun, plasma cannon, rocket launcher, and minigun. It should be noted that the rocket launcher is an undesirable weapon to use at both incredibly short range due to its explosive splash damage, as well as at long range due to its projectile speed. A separate formula is used when considering the enemy's rocket launcher, as it is not in fact desirable to be at point blank and facing an enemy's rocket launcher. This is likely to all seem rather confusing at this point, so it is probably helpful to do some step-by-step walkthroughs on what it is that I'm talking about, and eventually how this system all ties together. In the following scenario, the player has the long-range plasma cannon and encounters the bot who has a machine gun. If we estimate the range to be about 650 Unity units, we can see the disparity between the desirability and threat of the weapons being used. At this range, the plasma cannon is a desirable weapon, and the machine gun is not that threatening. Continuing the replay, we can see the bot's facial expression turn blue, denoting a transition to a fleeing state. Basically, in this situation, the bot is experiencing a high amount of threat, as the weapon it is using versus the one that the player is using at the distance they are apart is not desirable. This is behaviour you would typically see from a skilled or experienced player in the same circumstances. Let's see how this works again, this time with the bot using a plasma cannon and the player a rocket launcher. After being ambushed and taking an early hit, the bot quickly realises that this is also a bad situation. It again transitions to a fleeing state, understandable by looking at the disparity between the two weapon formulas at the estimated distance. This is a bad situation for the bot, and even though it beelines straight for the nearest resource, it is not enough to get itself out of the current predicament. But what about the previously discussed mechanisms, and how do they tie into this process? Well, assuming the bot's difficulty is quite average, the frequency of threat-based decisions is rather moderate. Additionally, the chance of making an expert-level decision is also adjusted to reflect what more skilled and experienced players would do. In the following scenario, with both the bot and player using rocket launchers, it would seem that an equivalent amount of threat would be observed between the two opponents. However, in this case, a personal buff the player has, that being the damage amplifier pickup, is making the bot experience a high amount of threat. At a difficulty of 5, a threat-based assessment is made relatively quickly, and with an estimated threat level of, say, 70, a decision is made right in the fuzzy zone. A priority density calculation is made in this fuzzy zone to grant priority towards the state that the original threat value is closer towards, in this case, fleeing. After a small RNG calculation is made, the flee state is the state that is chosen, and so the bot again transitions to fleeing. However, it unfortunately dies again. So far we have only shown this bot getting killed. Admittedly, it has had it pretty rough, but in the next encounter you will see it make a smart aggressive choice due to the player's lack of superior firepower at the range they follow. One thing you may be thinking is, why not use these modeled weapon formulas to make appropriate weapon choices? This is exactly what already occurs. Bots use the exact same weapon formulas to prioritize weapon usage at particular ranges. If a weapon is seen to be undesirable in the situation, the best weapon for the particular range will be equipped instead. In this scenario, we can see two bots fighting and changing weapons as the distance between them decreases. Unfortunately, for the bot on the left, the bot on the right has a shotgun, and getting as close as they do means that we have a clear winner. While there are some interesting components to this compilation of modeled player mechanisms, there is plenty of room for improvement. As mentioned, the weapon formulas are only using a static, two-dimensional perspective on their use in relation to threat. Because of this, their current exponential mapping is taking into consideration things such as expected target velocity already, and how desirable the weapon is to use because of that. If a target, for example, remains stationary, then a weapon such as a rocket launcher would not normally take the form of a bell curve. By introducing a third dimension, such as target velocity, we could revert the somewhat forced shape of the weapon formulas to their more natural, possibly linear, forms. The velocity of the target would therefore determine how effective the weapon is for the current situation, especially with slow-firing weapons that shoot non-instant hit projectiles. Additionally, if you consider some of the variables which could even change the basic shape of a weapon's formula, such as altitude with a rocket launcher, then you can introduce another level of complexity altogether. However, when it comes down to it, one's assessment of threat is, after all, a subjective thing. Everything proposed in this model is not to 100% accurately represent humans' assessment of threat in games. Such a task is likely an impossibility. However, I hope that this model does explain some of the intricacies missing from AI design that we as players understand relatively well, even if it is only unconsciously.
Cool. So that video I actually made, I think it was about 3.5 years ago now, but it still accurately represents what my research was. There were a few minor adjustments made at the end that kind of don't go into as much detail as what that model suggests. But I thought, look, I made that video for conference purposes, which I did actually show at a few international conferences, so it would be appropriate to show it here today. So moving on from that, I thought I'd just flesh out some of the aspects of the ThreatBot prototype and game AI that maybe the video doesn't go into as much detail regarding. So there was a phase regarding the design of this prototype and AI where I was analysing players. That needs to be said. And this was done using various studies, initially with Unreal Tournament 3 and then later on with Quake 3 Arena twice. And these studies were essentially designed to, first of all, get a grasp of how human players play in arena shooters. Essentially to have a library of footage that we could refer to so that we could say, okay, the player's doing this in this instance, how do we model that, especially if it's a consistent thing. In addition to this, it was also useful to ask the players certain questions about the opponents that they thought they were facing, and whether or not what they thought about the player matched their, I guess, understanding of whether that player was a bot or a human. And it was particularly interesting when they thought their opponent was a human, when it was a bot, and it was actually a human player. So they were saying things about the bot is too predictable when it's actually a human player that they were fighting. So that was necessary just to kind of get my head around the space, to kind of, as well as answer some questions from my supervisors who were, I guess, battling me at the time, contradicting me, saying, are you sure? Are you sure? Because that's a necessary thing that you need to be certain of when you do high degree research, when you make claims in text, you need to be able to back them up. So, as I mentioned before, one of the biggest observations that we made was that the programming of traditional bot AI seemed to lack any kind of implementation or understanding of how threatening a scenario is. And players understand this relatively well. I use the example of just using different types of weapons and the proximity that players are apart as I guess one of the core elements of understanding threat. Obviously there's a lot more there, such as the pickups, the proximity you are to walls. Your altitude is also pretty significant. I mean, if you think of a game like Overwatch, you're playing as Pharah, you're shooting rockets from a high altitude, you're going to do more splash damage with that. Your opponents are going to be looking up and saying, we need to get the heck out of here. Unless you've pressed your ult, in which case you'll die. Do you guys play Overwatch? Do you know what I'm talking? Yeah, okay. So, having said that, threat was observed to be a pretty important factor, and specifically the experience of the player was one of the variables which made this swing one way to the left or to the right. Specifically, what I'm talking about there is a more experienced player was more adept at understanding what a threatening situation was in your average first-person shooter. And this had an interesting relationship because not only could a more experienced player pick up on what's happening, what's occurring, what they need to do a little bit more readily, but they could also persist a little longer, which was also a noticeable activity. They would persist when they were in trouble and be successful. So that was something that required a little bit of experimentation regarding where we could take the model there, because some of those elements, as you would imagine, would be very difficult to implement, to make an AI understand beforehand the success rate or chances that it would have in a certain situation. So player analysis was definitely necessary. Eventually, it did get to the point where I needed to design a bot. Now, from the studies in question that were performed, we identified that the vast majority of players mostly did one of four things, and that was roaming, fleeing, engaging, or pursuing. Fleeing was an interesting part of the bot's AI, primarily because we found that as player skill and experience got higher, the tendency to flee also increased as well. So the more, I guess you could say, newbie a player was, the less readily they were going to disengage from combat and bug out. And partly that is related to, I guess, a newbie's understanding of the game's mechanics and how giving them a kill is counterintuitive to what you want to be doing in a first-person shooter, at least in an arena shooter. So eventually the design of a finite state-driven stimulus reactive agent incorporated basically these four states. That was the four states that essentially drove the bot's behaviour at any given point. On top of this, there was an element of dynamic difficulty introduced to the bot. And this scaled essentially with the, I guess you could say, expected skill that the bot had, which was just a numeric value. And this adjusted things like reaction times, their decision times, as well as how long it would stay doing something when it had chosen to pick a different state change. So what we also experienced was that a more experienced player would not do something for as long. So they would more readily change what they were doing at any given point, especially, as I mentioned, they noticed that the game state is changing a little bit faster. In addition to this, there was a threat bot variant that was introduced, and this used those threat-based heuristics that were described in the video to essentially make decisions with, instead of relying on simple game rules. So using the finite state machine diagram on the right, the game rules for the default bot, as I was calling it, was when it would simply say gain line of sight or have a reduction in its total amount of armor and health, then it would say flee. The threat bot variant, however, would rely on a calculation. It would look at its amount of threat and decide based on some variables and attributes how threatening the situation was and lean towards the state that would be most sensible to it based on its current difficulty. So this could essentially be a little bit more easily explained using that diagram, which is very similar to the one in the video. But essentially, the threat bot makes its decisions using what I dubbed a priority density equation. And the process there was that the bot would have a difficulty level, which would essentially have the two states in question have some kind of overlap threshold. Within that overlap threshold, a question would be asked, as in which state is more logical at this point, and that was essentially just based on where the threat value lay in that zone. And it would grant priority towards that state, as in there would be a greater probability of choosing the state that was more logical. However, again based on the difficulty of the bot, there was an element of randomness. So sometimes the bot would choose the behaviour that it wouldn't normally choose if it was, say, the default bot. And this introduction created instances where the bot would be in trouble but continue fighting. As I was saying before, where an experienced player would persist. So the variables would need to be lined up well enough and be convincing enough for it to actually select the other side of the equation and choose the state that was, I guess from an outsider's point of view, illogical, but from the bot's point of view, potentially allowing it to succeed. So basically, again, we observed that higher bot skill translated into a greater state threshold overlap, which is explained with that overlap moving down the state transition system and having a larger space to move in, which essentially modelled more experienced players pretty well, I think, at the end of the day. In addition to this, the bots themselves use barycentric calculations to calculate if the player is within line of sight. And that was really just done for more efficiency reasons than just using a massive collider or some of the other line of sight options you can get away with in Unity. And the bot also made use of a star navigation using a grid graph, which was a nightmare. I don't recommend doing that yourself anymore these days. Unity has really good options for navigation systems. Use them. Again, the weapon design in this game essentially used Quake 3 as a template. Ideally, the weapons that I designed for it were modelled off their counterpart in Quake 3 Arena, with some exceptions. And essentially, how this worked was that we needed to derive formulae for each weapon which described their utility or threat at specific ranges. And this was important because without this system, the bots would have no way of calculating how threatening this current situation was. So from the get-go, there was a very much design-driven focus of how these weapons should work based on their ranges. The weapons weren't implemented and then the AI injected later. It was very much a case of developing them both hand in hand so that they work with each other from an AI perspective early on. Oh, right. So the core threat values were calculated from the differentiation of weapons and ranges as described in that video. Basically, as you saw, the distance that bots were apart depending on which weapon they were currently using, that would describe an amount of expected threat. And now there was an additional level of a threat applied when a bot had the damage amplifying pickup. That was just a multiplicative coefficient. But generally speaking, when bots would fight, unless they had the exact same weapon, they would start doing different things, which is exactly what I needed them to do instead of just mimicking each other. That was always a problem with the default and threat bot, is that at the end of the day, unless they had the exact same weapon, they would continue just doing the exact same thing, which was not a viable option. Now, the weapon balance itself was something that was a lengthy process. I actually got my colleagues on several occasions to play test and balance these weapons for me, for reasons which I will introduce in, I think, the next slide. Now, that was a lot of fun because getting able to sit down with a group of people and talk about the design of a game. I mean, sure, I was the one who was making everything there, but getting their input was invaluable, because you very quickly realize that certain things that you're implementing are not how people would traditionally use them. So the way that you design it isn't as effective as you thought. And I think the railgun equivalent was a particular candidate for that. People were using that at a very long range, which I did not account for at all. So, initial interactions with the threat bot were good, but I unintentionally made the threat bot incredibly overpowered. So my first iteration of its design was hilarious because my colleagues could not get a foothold on it at all, which to me was a good thing because, hey, I've made this AI and you guys can't take it down. But I very quickly realized that this is actually inappropriate. I need to remedy this because players of equal or less skill than my colleagues are going to be interacting with this very soon. So there were some minor oversights and exploits that needed to be fixed. One in particular was that, this is a pretty funny one, the initial design of it did not account for you jumping on its head. So when someone would jump on the bot's head, it would stop stationary, like it stunned something in Super Mario. And I couldn't figure out what was going on because it just wouldn't move. It would not move at all when you jump on its head. You'd kill it, or it would just sit there. And I later realized that it's trying to move up. That is why it's just moving nowhere. That took me a month to fix that bug. That is nuts. But, you know, you're not getting any feedback regarding that with your navigation code, or I wasn't at least. So it was a big problem that my colleagues found a lot of fun with. But on several occasions, I do remember them specifically asking me, with different iterations of it, whether or not they were actually fighting a human player. So at some point during the development of ThreatBot, I could see this working very well, because the bot was doing things that just they could not get a handle on. It was doing unpredictable behaviour switching that would result in the bot winning more often than not. Eventually, there was a final user study associated with my research, which was mostly a decent success. It pretty much proved my aims and hypothesis, nailing it on the head. And essentially, the data analysis showed that players felt more competent against the threat bot, and it also enjoyed the challenge of facing it. So we used what was called a player experience and needs satisfaction survey to get that kind of result and measure them using all sorts of horrible data analysis techniques, which, I should mention this, I wasn't familiar with. I didn't realize that I needed to spend 6 months doing data analysis when I did a PhD. I do now. So if you want to do high degree research, be prepared for needing to do that as well. However, the main primary success factor from the final study was that participants preferred the threat bot over the default bot, even if it beat them. So there was an element there where more participants just simply enjoyed fighting this kind of AI than this kind of AI, even if it was kicking their ass. And that proved that the players were enjoying that bot significantly more. And this, as you would expect, allowed me to actually finish my dissertation, which turned out to be, I think, 287 pages long. But, you know, when you're writing a dissertation, you need to get to a result like that for you to be able to complete. So for me, doing a PhD took 4 years, just because of that reason. So developing ThreatBot kind of changed my design and research philosophy somewhat. I realized when I started doing this, I had grand plans for changing the way that this would work. And some of this involved using machine learning. There was a point where I was going to use some kind of genetic algorithm and evolve a bot. And I very quickly realized through reading papers and doing my own research and studies that those kind of interactions don't necessarily fix the important problems. One of which I realized was that it's the subtle interactions are often the more important ones. How the bot reacts in a given state based on some human element, such as the understanding of threat. I also realized that over-designing is bad. When you are making a system to do a specific task, sometimes, especially as a programmer, you want to, I guess, make it applicable and generic, maybe overinflated a little bit, so that it's future-proof. And sometimes that is not a great way of approaching things. There were countless cases of me designing the bot in a particular way to address what I perceived to be future issues with it that later just required me to rewrite the entire code anyway. So I came to the conclusion very early that address the problem at hand and keep it simple. I also realized that game design and AI should not be separate. And this was really more of a traditional philosophy. You make the game and then you make the AI to be injected in the game later. It's good to see that there are games being developed these days where the AI is developed in tandem, like something like Alien Isolation would be a good example of that, where the AI is actually the prominent feature of the game because it's the main enemy. So developing a prototype where I could design and develop the AI at the same time, I guess it kind of helped that I was the same person as well, because that definitely would, cleared some things up for me regarding the design of games, especially when you work in a solo team. This obviously means you don't need to necessarily reinvent the wheel, especially with regards to doing research. There's always this fallacy of coming into research and thinking you need to contribute to the field by developing something grand and new, using new technology. And that's definitely not the case when it comes to doing research. You can work on systems that exist, you can work on a problem that you've identified as being a gap, but you can use systems that work now or have worked for the last 20 years to answer problems, and they will do the job well enough. Player perspective definitely matters, especially when I was doing user studies and finding out exactly how people interpret these games, especially as I realized that it was slightly different from my own, which is an important bias that you do need to remove. And most importantly though, I realized that I am my own worst playtester. So never underestimate the value of playtesting. There were many times within the development of ThreatBot that I couldn't understand why my colleagues just couldn't do the one thing to win or to get around my bot. And that was just the wrong philosophy to have. When you design something, you inherently know all the ins and outs of its behavior, especially when it comes to an AI. You can't expect other people to just interpret that and pick it up straight away, even if to you it is obvious. So never consider your own playtesting work to be the gold standard there. That if anything, it should be maybe a first iteration of, but never considered in proper playtesting. And essentially, this all was injected, this design and research philosophy, into a game that I had the pleasure of developing over, I guess, a 3 to 4 month period at the end of last year. Now, the reasons for that was I was working at an institution in West End for about a year, and QUT basically, while I was working there, asked if, hey, could you come back and lecture for us next year? And I said, sure. But that unfortunately meant I couldn't resume my contract at that institute because it was a yearly contract. So I had about a 3-month break where I could essentially go on holiday or do something interesting, and I decided I'm going to make a game. This is a personal project of mine that I've wanted to develop since I graduated from QUT. And I decided I'd make a top-down shmup that I creatively called Retaliator. It's not a very creative name. That wasn't the point of it. The budget was roughly around $1.5 grand, which was mainly spent on certain assets that I, in that time frame, didn't have the time or resources or skills to produce myself. And in addition to this, there were extensive playtesting sessions. I'm not sure if anyone here I advertised that for. Sorry about that. But there were at least 3 or 4 for various reasons that I'll discuss very soon. And this was eventually showcased on Steam Greenlight in December. It didn't generate too much interest, but that for me was never the point of the project. The point was to get a portfolio piece out that I can say, that's what I can do. That's my area of interest. This is what I can do in this time frame. So today I'll actually show you the trailer for that. And I'll quickly discuss some elements of, I guess you could say, my research and design philosophy that I definitely injected into that game. Sorry about the frame rate there. I think my laptop doesn't like handling 60 frames per second videos. But yes, Retaliator was a project I worked on for about 4 months, I should say. And I had to work on all aspects of the game that I could. So this did, while I'm not, say, an animator and modeler, require me to investigate those areas as much as I could, having to fix a few models here and there and make a few where I could. although some of the assets that are used, I had to pay for. In fact, one in particular artist on Turbo Squid, I actually contacted about some kind of arrangement dealing with his models where I could use a large chunk of them at a reduced price, and that was a negotiation that we made. Cool guy. He makes some very good spaceship models. So essentially Retaliator is a top-down shmup that has an old school game design philosophy. Lots of explosions, lots of just killing things for the fun of it. But with some modern features implemented as well. You may have picked up there being a cursor flying around the screen. That's because you have mouse aim in that game, as well as various options for reducing or increasing your accuracy regarding the certain weapons you're using, which change the behaviour of the weapons too. So this was a game that had primarily a single-player campaign that originally there was supposed to be about 8 or 10 levels, but by the time I finished the game was reduced to about 6. But these could be played in co-op fashion locally, as well as there being a survival mode, which was for 30 waves, extremely difficult. I don't even think I can finish it these days, which was also co-op playable. And that actually raised an interesting problem with my game. Making survival co-op a thing was challenging. The variables and coefficients you needed to change there. So this game, one of its primary features was that there was an extensive weapons design and game AI programming session, or like I guess you could call it a test bed, where I was throwing a lot at the wall and seeing what was sticking. And this, even though I've said before, don't over-design something, it was more a case of me just going nuts and kind of exploring the field to the degree where I was comfortable with it. So it could have actually been produced in less time than it was, but I kind of just took this time as a bit of a liberation session to do what I wanted for once when it came to making a game. So, as I said, it was a game I always wanted to make. So, the weapon design, as I said, I went a little bit crazy. I spent an entire month on that because I did consider that element to be the backbone of the gameplay in this game. Without the actual raw interaction with the explosions, the sound, the visual aspect of the kinetic components of the game working together, then I wouldn't be able to proceed beyond that point. So that was very much the first thing that was designed in this game before the levels, before some of the enemies, and definitely before, say, the bosses in the game. So there are actually 18 weapons that were developed, and these all have varying levels of functionality, uses, cooldowns, situations where they could be applied. There is a use for this weapon type, and you can actually, if you were to play the game, choose and pick combinations of these weapons that you can employ at any given time. And this was essential to your, I guess, survival throughout the game, because the enemy types and the enemy combinations made it so that you needed to have a wide range of weapon types to progress efficiently. So primary weapons were unlimited, they had cooldowns. Secondary were very much situational with ammunition, and the tertiary weapons were those big heavy hitting weapons that you saw at the end of the trailer. This aspect of the game was heavily playtested. I think I did at least 3 playtests with a medium sized group of participants, originally naive, of course getting a few new ones every now and then, to give me feedback regarding that. And even right now, because the game I classify as being at an alpha stage, I'm still not happy with. This is still a phase that is still ongoing, assuming I get time in the future. The AI interactions were interesting, however. Coming from the perspective of designing, I guess you could say, the core gameplay first, the weapon mechanics, I was then making enemies to support or combat these weapon mechanics, these weapon designs. Let's make something that completely makes this weapon hard to use against this opponent type, where you will need to employ a different weapon type to get around it. So these were extremely simple designs. And the reason for that is because they don't last very long. And there would be no point in designing more complex enemies for this kind of game when you destroy them within seconds of seeing them. Now, admittedly, there are some enemies that were quite tanky that you do interact with for a long period of time, as you can see in that animated GIF. But for the most part, the enemies had very simple reactive behaviors where they see you, they engage with you. Depending on your position in the world, they change their direction, and they might transition to a secondary state based on what part of the screen you're in versus what part of the screen they're in. In particular, though, I did make a couple of enemy types that made quite a challenge for certain players, especially when they weren't expecting them in certain configurations of the enemies. And one of these in particular were the regenerators. All this ship did was jump around and sit behind other enemies, healing them. That originally made my game almost impossible to beat because most players weren't selecting, say, the weapons that could get around it. So this was interesting for me from a playtesting perspective, seeing players run into this wall of how do I kill these things? They're just stacking enemy types up, I can't get around them. My solution to them, because I wasn't giving them too much advice, was to change your setup. And they would. And all of a sudden you'd see some progress much further than the next. So that was, for me, an enlightening experience to see players get past this hurdle, mostly by themselves. I'm sure most of them would have done it automatically, eventually. But more rewarding to see this wall, this predicted wall, actually be something that did exist in playtesting. I intentionally designed the regenerators to be as annoying as possible. They were, and it just created a more interesting experience from a playtesting perspective. So I should actually mention there is a demo for this game that you can download from the link that I have at the end of the slides, where I think the regenerators are in, if you did want to have a go at not necessarily taking them down themselves, but when there are dreadnoughts on the screen, those aren't dreadnoughts, they're only frigates, it becomes very annoying, let's put it that way. But good annoying. Most players were saying it was fun, but on the level of flow where it's getting to the frustrating point. Additionally, the bosses were an interesting element to introduce in this game because they did need to hold up in, I guess you could say, 1v1 combat against the player. And this required a little bit more design for these AI agents. They were mostly driven using a very simple finite state machine, but still on the same kind of simplistic level as the other AI opponents. Now, making these have some kind of balance between being a bullet sponge and having interesting mechanics was also a fine line to tread, because you could simply just inject health and damage into these monstrosities that float around the screen, but it very quickly becomes boring when you figure out that you can just rotate around them and eventually you'll kill the thing. So needing them to transition between states where they did slightly different behavior was a necessity to keep that kind of combat pattern from happening. I think like the mental process that I had at the time was to make them almost like a raid boss or a simple boss in, say, WoW, where they will do one thing and then do another thing and maybe a third and then come back to doing the first thing. And the idea for beating them is that you memorize those patterns and figure out how you can get around them. Using the weapons, using the different ship types you could employ. This was difficult to do in co-op play because with 2 players on the screen, a lot of the mechanics became redundant. especially when the boss would just simply want to beeline towards a single player. The other player in question would just be able to blast the boss away. So to a degree, this required changing a lot of the timings of things, and also the reacquisition of the other player's target was an interesting problem to undertake there, to make it seem a little bit more interactive for the other player at that time. And also the final boss is an absolute monster. That was, I guess, a narcissistic level of development went into that, just to make it as difficult as possible without it seeming completely broken. Because the idea was that you'd get right to the end of killing this thing and then it would kill you. And that would happen over and over again. That balance was something I worked on for about a week. And it still needs a few changes, but I'm pretty happy with it where it is right now. So, some of the conclusions I came from developing Retaliator was that some of the design and research philosophies that I had through my research, that I did employ in the development of it, were pretty much applicable to a game of this size. It worked quite well with what I was trying to achieve. I also found the experience of developing a game by myself to be a worthwhile experience. So if it is something that, particularly as a student, when you come out of university and you don't have that portfolio project, make one your own. I highly recommend it. Maybe not spend $1.5 grand and 4 months on it, but make something that you can really call your own, that you can say that this is what I can do as an individual by myself. I found the learning experience to be invaluable, particularly because I had to recall techniques, programming techniques in particular, that I hadn't employed for years, that I hadn't used since actually programming in C#, learning that at university. So I found the simple fact of running straight into problems and not having like an absolutely adept programmer to guide me through it to be a valuable learning experience, to have to work out those kind of problems myself. Some of the vector math necessary to move ships around in coordinate space was interesting and a lot of fun. Don't work 18-hour days though. This was something I did, and it did affect me. I should mention I'm epileptic. Nearly had a few instances there where I wasn't taking enough care of myself, and that really is just because I was enjoying the experience so much. To be able to wake up and walk to my computer and start programming and say, I should get breakfast soon, and look at my watch and say, oh, it's 10 o'clock at night. Yeah, I should get breakfast soon. Continuously, maybe don't go that far, but at least employ some degree of, taking care of yourself properly. Finally, don't underestimate the value of playtesters. As I've said multiple times in this presentation, I've found their perspective to be invaluable. Because, as I mentioned before, you are typically your own worst playtester. You have a much higher, much deeper understanding of your game, and getting playtesters from varying demographics to try it out should be an essential requirement for you to balance your game effectively. So definitely do it at various stages of your game if you can, because it will guide the rest of the development. You will have less problems in the long run. So just quickly, again, from this point, I'm still lecturing at QUT. I will eventually probably either work on Retaliator a bit more, because especially with Steam Greenlight kind of going under, I think, I'll need to maybe work on it a bit more and see how else I can advertise the game. So I'll either work on Retaliator or another solo project in the future. I'll definitely continue researching games, assuming QUT gives me the time and money to do that. And obviously I'm never going to stop playing games, so hopefully you guys don't as well. So there's just some links regarding some of the material I put in here. And that's it.
Thank you.
Cool.
We can answer a few questions.
Oh, sure. Yes. Completely forgot. Dylan.
So inside of your PhD, like kind of mapping all the different the threat values of like two different players, was something that you found when you were researching with the actual players that those, because I'd expect that those curves would change depending on how experienced you were with the game. Because like if someone who's never played a game before might not know a shotgun's not very long range.
This was a constant struggle I had with developing those curves because the final implementation, they were static. And I wanted them to be dynamic. I wanted those curves to move based on elements in the game, based on bot difficulty. It's a subjective thing, first of all. Like the power level of a railgun or a sniper rifle is very much dependent on the skill behind the person. Someone could make that effective at very close range. So, yes, for me it was something that I did identify as a definite problem, having those curves, those values associated with them as static things that didn't change, reduced the accuracy of the model to a degree. I think if I was to work on ThreatBot, God forbid, I'm trying to forget it, honestly, that would be the first thing I would adjust, because it's the core component of what's driving it, and it's static. It's not something that is changing it to a dynamic degree, which I feel that players do, depending on how good their day is, for example. Yep. Yes.
So I think you got into us a bit when you got to the co-op section of Retaliator, but it's definitely a different situation when you got one-on-one versus one versus many, and sort of. Could you go into more detail about how you react to multiple different agents and threats?
So the problem I encountered there was that this game wasn't originally going to be co-op, and I developed it to be a single-player experience, and then later slapped co-op into it, as I really should have thought about in advance. And this made bosses redundant. It made them, first of all, they wouldn't acquire a different target. So there was a whole new system I needed to introduce there to make them consider, hey, there's another guy shooting the crap out of you that you're totally ignoring there. Switch to them and do something about it. The other thing is that getting a balance between how tanky they were versus, say, what level or how far you've survived through survival mode was also difficult, because if I just talk about survival mode for a sec, survival throws enemies at you every 30 seconds. Not in a batch, but in a controlled spawn rate. 30 seconds later, there's a new kind of enemy differentiation it'll spawn at you. When it comes to a boss wave, it spawns a boss. And if you don't kill the boss in 30 seconds, then now there's a boss and enemies flying into you. So there needed to be a balance between two players who could kill the boss quickly and then sit there waiting for a while going, there's nothing else here, or the situation where they couldn't kill it quickly because it was too tanky. And that required just simply a lot of playtesting to get those numbers right. More than I would have expected. Like, you kind of change it 10% less, 10% more, and it completely threw things out of whack. All of a sudden, certain weapons were perceivably useless against this boss because it's moving around too fast at its last 20% of its HP because of the coefficient that you've introduced. So, lengthy process, basically. Yes?
Just in terms of the human players, do you get any feeling for their level of experience, whether the more experienced ones actually were doing more threat assessment because they had more time for threat assessment, because they were more competent in handling other aspects, or were they actually doing threat assessment at the expense maybe of some other aspects?
So this was also part of the video analysis session that I conducted when I initially got a lot of that footage through. There was obviously, because we did a few different types of user studies, one where they fought just against a bot, the next one where they fought against bots and other humans and didn't know who was who, and they had to answer questions regarding that, and another one where they fought against the threat bot in question that I developed. And throughout all of those user studies, there were questions being asked regarding, how you are interpreting the situation. We weren't calling it threat initially, but we had a hunch that there was something there that human players were doing that bots were just, whatever, I'm just going to do what I'm programmed to do. Highly skilled and experienced players were quite visibly taking into account more aspects of the situation. It was just to a degree where an experienced player would kind of, I guess you could say, idle for a second or two before walking into a room. There were situations such as that. There were situations where a highly skilled and experienced player would hit low health, like their health would start flashing red and they'd just bail immediately. They wouldn't care how close they were to killing the target. If they could flee, they would. And that was something that we noticed that the less skilled players were doing at all. So we were confident that when we noticed this strange disparity in behaviour, that we were onto something there. And that was actually difficult because up until that time we hadn't considered there being a significant skill gap in the players that we were asking to play. We just assumed that everyone will kind of be around the same level of skill because we asked skilled first-person shooter players to play. But what we later realised is that even in that category, there were a large number of maybe not so skilled and skillful players because, again, it was based on their own subjectivity of how skillful they were. So we needed to ask them that. How skillful do you think you are? But then we needed to measure them as well. And there was a whole list of variables and checks that we needed to do there. Has that answered the... Okay, sure. I can't actually remember what I was trying to...
Did you actually expect to find such unique behaviour between the experienced and unskilled?
Initially, we were just hunting for something. We knew that there was something that we could model. And I can't remember what the list initially was versus what it came up to be. But I think it was maybe 5 or 6 things we predicted that would be a thing that we could model, that we could then put into the AI. But the one that kind of was a clear cut was this element of experienced players just having a degree of assessment when they came into certain situations. So I guess you could say, yeah, we were expecting that. Yep. Dylan.
With a lot of those classic deathmatch games like arenas, I guess it's kind of a player strategy that I've formed, but maybe it was also like a design perspective on it, was that if you are being measured based on how many kills you get, the only thing that matters when it comes to deaths is that you're giving other people kills. But if all you care about is getting first place or not, then you only have to worry about one person's kill count, which is either going to be the winner or the runner-up if you win. And so when I play those games, I typically don't care too much if I die, especially if it's against someone who I don't think is going to be that runner-up.
Yeah.
Is that something that's kind of, because if you say that experienced players tend to play more conservatively, does that fit still into like their goals of winning and how?
For the players that were consistently doing the best, they did have a high degree of self-preservation. There was, and it was more just, them not giving kills away means that the other person can't catch up to their score. So while I didn't enjoy using, say, kill-death ratios, because I feel that's a very loose, arbitrary way of measuring skill, it tells you nothing. It was taken into consideration, and the players that had, say, the highest kill-death ratios, or the best kill-death ratios, were observed initially first, and sure enough, they had incredibly strong self-preservation-like behaviours. Which in some ways guided the rest of the study from there. We said, okay, what are they doing in particular that's doing this? And sure enough, they're less aggressive. What are they doing right now? This guy is just going for a walk. But sure enough, they're picking up a better weapon, getting health, getting armor, coming back and engaging. Sure, during that time they may have lost, may have not gotten a kill or two, but in the end it worked out better for them. So.
Okay, so your measurement of skill was based more on kill-death ratios than actual winning the match?
Not necessarily. As I said, I didn't like using kill-death ratio. The assessment of skill was a very lengthy process of looking at each participant's video and making a measure of it. Because we found that the initial, what they were saying, how skilled they were, I think we were just using a metric out of 10, was completely off. It was not accurate at all. So we needed to go through those videos, make I guess you could say, a model of what we thought for this particular first-person shooter was a skillful set of attributes to have, and measure them one by one. Yeah. Yes.
I guess a bit related to Bill's question there. I am wondering how your research would relate to a very different type of game objective. What you said made sense, and I hadn't really thought of some of the things the way you present, so it's very interesting here. But again, perhaps not maybe capture the flag, playing more some of the battlefield maybe game modes where the objective is to get the bomb to the enemy base. So a lot of the time you will be sacrificing yourself.
Absolutely. There was a long explanation, I think I even had to put in my thesis, where I was specifically saying this only applies for deathmatch. Because in Capture the Flag, I've even done it myself, where you're trying to capture the flag, you just have to take hits for the team over and over and over again to penetrate their defenses, which means you're dying a lot, which from a statistical standpoint, if you look at the data, says, well, they suck, right? But you could be the best player on the team. You're the one with the strategy, making pushes. You're going to win the game eventually from your actions. But from a, if you were to look at the data itself, just the numbers, it looks like you're having a really hard time, whereas you're not.
I guess from the meta game, it may still apply because in those objectives where you only care about getting there once, you still don't just throw away your lives. You typically are being conservative until you can make that
exactly, yeah. So there's...
The game is usually a ticket counter or something that prevents you from unlimitedly doing this.
Yeah, like if there is an objective-based time-driven sequence like, I don't know, pushing the payload in Overwatch, when stay with your team, otherwise you're just going to waste the potential push you could do. Yeah, like those variables would need to be considered if the game type was changed. Thankfully, we weren't walking into that territory, or I wasn't expected to, which was really good.
Next thesis.
Hair rip out time. Yes?
In relation to the logical behaviour, that did you stumble across that, or were you actually trying to model like in a logical bot, for example, like there's an enemy at far distance, I'm going to choose a melee weapon. Or
right.
Like a very poor version of a threat bot or an unskilled player.
I'll be honest there, that was almost an accident. I was considering let's just make them make changes to their behaviour based on the weapon models. And it got to the point where it was like, shouldn't they check to see if they have a better weapon before they do that?
Yeah.
And we did, and all of a sudden the dynamic was changed significantly. Yeah. So I'll be honest, I hadn't considered that until I just asked myself the question during development. Just change your weapon type instead of changing your behaviour, which became as a higher level of priority. Change your weapon type, now make a decision based on what you want to do. And we, or at least I, didn't anticipate doing that at all.
Yeah,
So
it'd be cool, like making actually bots that actually sort of resemble unskilled players for someone to actually go against.
Yeah. Yes.
You said you didn't go down the machine learning path for your thesis, maybe it was the time, but with the curves for the weapons, if you had, rather than that sort of knowledge-derived curve or observed curve, if you had more a machine learning utility curve that could be potentially different, like something to consider?
Definitely. That was actually another chapter in my thesis where I was talking about potential improvements for this, was that we haven't used machine learning in a few sections where we probably should have for, say, those weapon formulas, because at the end of the day I was just making an educated guess that was based on my own subjectivity, which is different for all the players. But even that curve itself, whatever that looked like, could have been better developed by mapping actual player activity. What is the range that the railgun or the plasma cannon seems to be most effective at? Let's make that the highest point instead of maybe I had it a bit too high or maybe I was completely wrong. But yes, definitely that would be a great area to inject a little bit of machine learning to get those formulas more correct. Yep. Yes?
How much did you find navigation, awareness of particularly navigation, affected the overall AI and design sort of thing, in terms of, can I see something, can I get somewhere, almost where the motivations for the rest of the game?
So from memory, the enemy AI had, both the default and the threat bot variant, had just very basic wants and needs. Like if it was low on ammo, it was low on health, it would just go for that during its roam behavior. And it would just continuously fill up. If it then encountered an enemy player either through visual stimulus, audio stimulus, or getting shot and looking around, then based on the values that it has with its armor, its health, its weapon, would it choose to engage or not, or flee. And I was going to have a more complicated pursue behavior, but currently the pursue behavior is go to the last seen location of the player and have a look around. And it was just those behavior types that seemed to be enough, because what we observed was that was what most players do. If players are chasing someone, they'll go roughly to where they last saw them, and if they still can't see them from there, they'll just decide to do something else, completely random. But navigation-wise and kind of detection-wise, I didn't encounter too many issues there. That was something I'd kind of been working on for a while prior. I'll admit, it was my honours research. That system that controlled the detection and aiming was my honours, and I just essentially plugged it straight into my PhD. Yes?
When the bot flee, where does it flee?
This is an excellent question. This was a month's work of trying to figure out how that works, because when I sat down to program fleeing, I was like, yeah, this will be easy, I'll do this in a day. And I remember this so clearly. I sat down and was just stumped because I couldn't figure out what I do when I flee. It's like, yeah, sure, you just go around the corner or you break line of sight and go away. Representing that in code is hard because you have to give the AI some conditions. If this is happening and do this while this is the case until you break line of sight, it'll just go off and do a stupid thing, right? It'll just go forward, it'll go past the enemy, and it'll just do stuff that's illogical. What I ended up writing was a function that essentially points it in the direction of the closest valuable resource that is A, not within line of sight of the enemy, and B, closer to the player than it is to the enemy, which would make the AI flee in the opposite direction towards something that's useful, like health. Usually it was health. And that became fleeing, and it worked incredibly well. But that was not something I just wrote off the bat. It had to be a process of sitting down and evaluating what does a human player do when they need to run away from the situation and continue running away from the situation. Something like that. Yes?
Sort of on that, I guess players do learn that there are certain areas in the map that are safe spots, and then they can remember those and say, okay, I know where that is, I can go to that spot. So it's almost the same sort of thing as that. So you could even have spots that aren't pickups, just kind of safe spots. And increase that fleeing as well.
I never actually thought of that, mainly because the map that I had in the game was very symmetrical, and I understand what you mean. Like, there are definitely places in a lot of the maps that you'd play first-person shooter games in where you can kind of chill for a bit, because the likelihood of encountering someone here is low. But in the map that I made, it was a lot of clear line of sight to a lot of things. So really you needed to kind of keep moving, because at any given point, you know, someone could just pop around the corner and now you're busted. So
that
yes.
was actually the motivation for my navigation question, because fleeing from a navigation point could be choosing both a goal location and changing, working with the grids actually simplifies things to think about. You populate it in terms of not distance but risk. Trying to find a path to the health perhaps, or to a place which is covered from your threats.
Yeah.
Change the way you think about it.
In my implementation, I was vaguely considering directly adjusting the A* code that I was using to navigate with. But that was, I can't remember the exact reasons, but it was getting bloated enough for me to not want to throw into the heuristic component of that the potential to run into the enemy, because then that required, you know, kind of proximity-based calculations and the line of sight aspect of the enemy, which I was just like, oh, this is going to be far too much work for little gain. But yes, ideally there would be directly in the pathfinding component some aspect of, I want to get here and it's, you know, the player is closer to it than me. Let's make a path that is going to hide me from the player while I do this. My fleeing behaviour didn't do that, it just legs it the other way. But ideally, yes, you definitely want to consider the risk factor of getting to point A to B and how you can work around that. Yes?
When your bot was doing things, was it doing any prediction of the player's likely position?
No. It's completely a stimulus-based reactive agent. And that was more because we had a conversation at some point about, do players really do that when they play games? Is a player who's playing a first-person shooter thinking about where the last location their enemy was 15 seconds after they encounter them, or maybe a shorter window, maybe let's say 7 seconds. And some of them did portray that. Some of them would hunt them down or perform behaviour that looked like they were trying to anticipate where they were going to be. But the vast majority didn't. So we decided that that was an element that we wouldn't implement in ThreatBot. It would just be purely, I've seen you, you've seen me, we're going to fight. If you break line of sight, I'll go to where you were, but after that, it's not going to try and make a guess. It's just going to keep doing its thing.
Cool. Thank you very much.
Okay, cool. Thank you.